Zoom. I want to zoom. Zoom. Yikes, I don't want to do that. Come on. Okay, I guess we'll deal with this. Ah. Zoom. Oh yeah. Okay. Let's do for boron. Let's say boron here. Here. For boron. We know it's 2-3. But we know for boron there's 5 electrons that we got to put in. How do we know that? Because boron has 5 protons. And if it's going to be neutral, we're going to put them, all 5 electrons somewhere. So here's how you do this. This is how you use this chart. It's nice and color-coded for you. This red is a first shell. This is a second shell, third shell, fourth shell, fifth shell, sixth shell, seventh shell for your electron shells or energy shells. So if you have 5 electrons, you just simply go from left to right, filling in the boxes. Just left to right. So I'll show you. For boron, you put in a little mark right here. 1, 2, aha, I ran out of space. Now I go from left to right, top to bottom. Okay, I've got 3 the next one. I've still got 3 to use up. 1, 2, 3. So there are 2 electrons here, 3 electrons here, so therefore my configuration's 2-3. Well, that's pretty easy, Mr. Sad. Well, yes, but now let's do a more difficult one. Let's do an element like, I don't know, let's try titanium. Titanium. Where is titanium on the periodic table? Let's not do titanium yet. Let's do scandium. Scandium's element number 21. Yeah. No, let's not do scandium either. Let's do magnesium. Magnesium. There we go. Magnesium's element number 12. So that means we need to put, if it's a neutral magnesium. Now, if it's not neutral, let's say it's +2, that means there's less electrons. If there's -2, then there's more electrons that we need to fill up here. But let's just say it's neutral. Okay, magnesium, it's got 12 electrons. So we'll go over here. I'll use a different color. Let's use asparagus. We'll put in 12 electrons going from left to right. Here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, great. Notice underneath here, there's little parentheses and it says 2, and there's little parentheses that says 8. And little parentheses that says 8, 2, 10, 6, 2, 10, and so forth. These tell you how many boxes are right here. So if they're completely full, or if you just want to add your electrons together without actually filling in these boxes, you can just do that. Okay, so there's 2 electrons in this first shell for magnesium. There's, instead of 3 this time, there's going to be, it looks like 8 in the second shell, and there's 2 in the final third shell. So this is going to be electron configuration for magnesium 2-8-2. All right, that should be pretty straightforward. Now I'm going to do a weird one where we have to go backwards, sort of. Okay, I'm going to do titanium. Titanium's element number 22 on the periodic table. I'm going to use cayenne for this one. This is a reddish color, cayenne. Titanium. There are 22 electrons for titanium, so we're going to have to go and plug these electrons in their boxes right here. So we'll say we're going for 22. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Oh, now what do we do? If we're going left to right, and we've got 18 so far, and we got to get up to 22, we can't just jump over this because that's the next one if we go from left to right. So here's 18, 19, 20, 21, 22. Alrighty then. That means that there are 2 in here. There are still 8 electrons totally filled up in this row. But now how many electrons are in this yellow row right here? We have 1, 2, 3. Well, we've got 8 there. I can read that right there. And there's 2 more. So we've got a grand total of 10 in this third row. And we've got 2. Haha! 2 in the fourth. So this is what it's going to look like. It's going to look like 2 dash 8 dash 10 dash 2. That's the electron configuration for titanium. Holy crap, this is crazy. Right. Now, if you have more electrons to fill up, like these are somewhat small atoms right here, well, you can fill up any element on the periodic table using this chart. It should fit any element. So let's do a large one. Let's do up to, I don't know, let's do up to 48. Another way you can think about this is that you can, for yourself, if you want to, or if you're going through a lot of these problems, you can kind of say, okay, well, if you fill in these electrons, this is 22. Well, if we go 23, 24, 25, 26, 20, wait, that's 22. 23, 24, 25, 26, 27, 28, 29, 30. This is where 30 is. So you can mark that as 30 if you like. That helps me sometimes. That means that if you've got any element above 30, you at least have all these boxes filled in. Okay? Let's say that if you go up to an element like cadmium, let's say cadmium here. Cadmium, CD, this is element number 48. So we've got 30 right there. Add another 6 to that, it's going to be 36 at this point right here. 36, 37, 38, and you get to 48 by going all the way to the end over here. That's another 10 right there. So cadmium has all of these boxes from here all the way down over here, all of these filled in. So let's count up the electrons in each box for cadmium. So the first row is going to be 2. I'll just mark that down now. Second row is going to be 8. That's the maximum it can fill. Third row, it's totally filled. Looks like 18 total because I'm using these 8 and that 10, 18. Now I go down here and I look, okay, that's 2 plus 6 plus another 10. That's going to be another 18 for cadmium. And then finally, the fifth row, we've got 2 in the fifth row. Okay, that's how you do a couple electron configurations. That's really what you need to practice now. There are a couple sites that help you practice these, and I have to tell you that there are a few exceptions to these rules, to this rule that I've told you right here, this Aufbau rule. And this is what really irritates me about chemistry, is that there are exceptions. Even though this is a nice little rule, this is a nice little box organizing principle here, or Aufbauprinzip, but there are exceptions. But in this class, we are not going to really treat those exceptions with any kind of validity. We're just going to use this structure, this rule, as the truth. So no matter what question you're getting, even if it is a small exception in chemistry in a real life, we're going to use these boxes as the guiding principle to how electrons are packed around atoms. The exceptions, they are interesting. Believe me, they are interesting. It's interesting why they stack in there certain ways. It has to do with their kind of like mutual repulsion in these particular kinds of configurations, but it's all really related to stability anyway, and we don't need to go into that. Let's just do the structure like this. And if you're interested in doing the SPDF method, believe me, I can help you with that. Only if you're interested, I can teach you that. Just let me know. Just give me an email or something. Because later on in college, you might be asked to do that for chemistry. Okay, so I hope this helps with your electron configurations. Just practice, practice, practice makes perfect, and I think I can give you some practice simulations as well. So good luck with those. Good luck with the workbook problems, and email me if you have any problems. Okay, bye.